Hey, what's going on, guys? This is JU, and I'll be talking about memory management for Windows operating systems. All right, first things first is what is memory management? It allows you to check how much memory needs to be allocated to processes that decide which processors should get memory at what time. So, it tracks whenever inventory gets freed or unallocated. Allocates the space to application routines. It also makes sure that these applications do not interfere with each other. All right. It also helps protect different processes from each other from canceling each other out or whatnot. It places the programs in memory so that memory is utilized to its full extent. There's a couple different types um, of memory. There's a SATA 1, 2, 3, and a eSATA, which is an external SATA. The most recent SATA type is SATA 3. All right. All right. So we were talking about allocating memory. All right. And allocating memory is the process in which computer programs are assigned memory or space. There's two main types. There's low memory and high memory. Low memory is where the operating system usually resides in this, and high memory is the user processes that are held in this. Okay. All right. So we'll be talking about partitioning first. All right. It's a logical division of storage space on a hard drive. All right. There's a single partition which encompasses the entire hard drive and multiple partitions that divide up the storage space on the hard drive into different partitions. All right. There's two main types of partitioning. There's a MBR, which is a master boot record, and a GPT. We'll talk about the GPT in a little bit. First, we'll talk about MBR partitioning. All right, so Windows supports two types of disks, basic and dynamic. So how you get to this first is you come down here to the start menu, right click, go to disk management, and your disk management pops up. All right, over here it tells you your type. You can have two different types, a basic or dynamic. All right, so a basic, it uses a primary or an extended partition, and dynamics, it's like partitions and logical drivers on a basic disk. All right, we'll talk about dynamic disk in a little bit. First, you can come down here and see that this is basic. All right. All right, so as you can see, this is the hard drive right here. All right. In that hard drive, we can see that there are broken down into three partitions here in the basic type system. As you can also see is there's a file system. This is not, we're not going to cover file systems here. That will be recorded for another time. All right, and that tells you the status of the hard drives or the drives. They're all obviously healthy. This is the storage capacity for each drive. And this is the amount of space that you have left that's open or unallocated space that you can possibly use. Okay, as you can see, we have multiple partitions here. Alright, so if all of this were combined together, it will be a single partition. But currently, it's broken down into multiple partitions. Right? So when you're using a basic type, each physical drive can have up to 4 primary partitions or 3 primary partitions and 1 extended partition. Logical drives are defined within an extended partition. So you can have up to 24 logical partitions within 1 extended partition. All right. Logical drives are a storage unit and not a partition. Make sure you get that. All right. All right. It's supported by all operating systems and only supports volumes made up of contiguous disk space, meaning within the disk, each allocator and unallocated space needs to be next to each other. So one major thing that you should know about basic type is that from basic, if you right click, you can convert it into a dynamic disk. But if it's on a dynamic disk, it cannot, I repeat, it cannot be converted back to a basic disk without losing any data. So if you're going from a basic to a dynamic disk, you are allowed to keep all the data that's on the hard drive. But if it's vice versa, you will have to wipe out the hard drive or you will lose all the data. So we'll talk about dynamic disk really quick. So a dynamic disk, you don't need multiple partitions. It has supports up to 128 volumes that use non-contiguous disk space. All right, volumes are like partitions and logical drivers on a basic disk. So single volumes contains disk space from a single hard drive, contiguous or non-contiguous. Span volumes are containing disk space from multiple hard disk drives grouped as a single logical volume. So single volume would be this entire thing right here. This hard drive. Now if we had another hard drive on this virtual machine, and a span volume would say I mount this right here onto another hard drive, creating an expanded volume or span volume. One major thing that you should remember is that basic hard drives or basic types, you can install operating systems on that, but with dynamic you cannot install operating systems on it. All right. You do need to upgrade a basic disk containing operating system to a dynamic disk after the installation, but that's the all right. Earlier we were talking about GPT partitioning, which is a GUID partitioning table. All right, GUID um, comes from a globally unique identified number. All right, it's slowly becoming the new standard and replacing MBR partitioning. Every partition on the drive has GUID or a globally unique identified number. Each partition worldwide would have its own unique identifying number. It can be basic or dynamic, supporting up to 128 partitions. It can store multiple copies across the disk, so recovery is useful when data is corrupted. CRC or cyclic redundancy checks the data that is intact. If data is damaged or corrupted, it attempts to recover all that data from another location on the disk. Alright, the next thing we're going to talk about is defragmentation. So defragmentation, why do we do it? Fragmenting is when memory is stored and it gets broken down into small blocks and it's scattered across the hard drive. There are free spaces scattered across the hard drive also. Alright, what we're doing with defragmenting is reorganizing the blocks of memory into a contiguous form and kind of like combining all the free spaces into a single block. There are multiple ways to defrag your hard drives, alright, but the fastest way that I'm about to show you is just go to File Explorer, alright, you go to this PC, you're going to right click the drive you want to defrag and go to properties. Under there, you can there's actually a couple things you can do here. You can do a disk cleanup, which will clean up all the unnecessary files or folders that's unused that haven't been used in a long time. All right, so you're gonna come to Tools. Right here, you're gonna click this button, Optimize. And once you do, you're gonna click this button and click Optimize, which is going to defrag your drive. Alright, so that's defragmenting for you. It's really quick. It depends how long it takes with your computer. And hopefully it could increase your storage space, or, help you out there. All right, so we'll quickly do an overview about RAIDs, or also known as redundant array of independent disks. But we cannot show you because we can't record under the BIOS. Alright, so a RAID is a disk subsystem that combines multiple physical disks into a single logical storage unit. Depending on the configuration, a RAID array can improve performance or provide fault tolerance or both. Alright, there's three ways to RAID. You have hardware, software, and operating system. With the hardware, it uses a special control card. It's the most expensive, but provides the best performance and is the most reliable. With software, it uses a driver and a system CPU. Slowest form, many motherboards provide a built-in support for the RAID. Alright, with the operating system, it uses the RAID features within the operating system. It uses the system CPU, which uses for RAID operations, and the performance is typically better than software RAID. Alright, so let's talk about different RAID levels. Alright, RAID 0, also known as striping. It breaks data into small units or blocks and stores them across a series of disks by reading and writing all disks simultaneously. It increases the performance. That's the main goal of this. But it does not give fault tolerance. Failure on one disk means all data is lost. Okay? With RAID 1, it's also known as mirroring. Alright? It stores data to two duplicate disks simultaneously. It's like a backup. If one disk fails, the data that's present on the other disk is immediately switched from the failed disk. It provides fault tolerance for a single disk failure. Remember, a single disk failure. It does not increase any performance, and it does require two disks. Alright, that's why we couldn't show you any of the options earlier. 50% is overhead, meaning that data has to be written twice, so only half the disk space is available. Alright, we're going to RAID 5, which is striping with distributed parity. It combines striping and parity, so we call it RAID 5 or RAID 0+1. It provides fault tolerance for a single disk failure. It increases performance with read options, but slower with the write operations. It requires a minimum of 3 disks. Okay. We also have RAID 10. It's stripe of mirrors. Stripes data across all mirrored pairs and across multiple disks. A paired or a set of disks. Okay. You need at least a minimum of 4 disks, so that's why we need set disks. If 2 disks are in the same pair fail, all the data is lost. If one of them fails, it's perfectly fine. It'll switch right back to the other disk, and that's where the redundancy plays a huge role. RAID 10 is really expensive, but it increases both performance and redundancy. Well, that's it for you guys. I hope you got something out of it, out of memory management, why it's important, and hopefully I can catch you guys later. Thanks.